to the next part.
Actually, sir, many latecomers were there, sir. I put a message in the group
Okay.
that these are those who are given utterance and those who are not joined will be marked as absent. Now they have joined. All those 5 students have joined.
Okay, fine.
So they are latecomers to the lab.
Okay, okay.
Yes, sir.
Okay, let me continue. Just like we discussed the positive clipper. That means you can see here part of the positive cycle was clipped. Similarly, we can see the negative clipper. Again, in the negative clipper, we will have parallel clipper and we will have series clipper. The only difference is the diode direction is going to be reversed. You can see here in the positive shunt clipper, the diode was downward, and in the positive series clipper, diode was towards left side. Now in the negative shunt clipper, diode will be upward, and in the negative series clipper, the diode will be towards right side. So obviously, whatever I discussed in the earlier circuitry, the same thing is going to hold good here also. Right? Now, this diode is always remaining forward biased at 3 volts. Okay, you can see this here. The diode is always remaining forward biased. Now, when the input is at 0, output will be 3 volts. And input when it is rising, until the input is rising up to 3 volts, diode is forward biased. At that time, the power supply, DC power supply, as well as the AC source will be in parallel. When they are in parallel, as I already told you, DC is powerful. So you will get that V reference 3 volts only here. But what happens when the input voltage goes beyond 3 volts? When input voltage goes beyond 3 volts, this particular diode gets reverse biased. The diode will not conduct anymore. When the diode does not conduct anymore, whatever is the voltage here, that is going to come here and it is going to pass through the CRO. That is why you can see here, the output is coming only for this much portion. The remaining portion is gone. What about in the negative cycle? In the negative cycle, the diode is on always. There will be DC here. So because of which, you will not get the negative cycle at all. Okay, you may keep getting that 3 volts there. Now once we connect a capacitor in series with this circuit, and we can always see only the clipped AC waveform, only this much. If you don't connect a capacitor here, you will be getting that DC 3 volts also, because diode is conducting. Whereas in the oscilloscope, we have something called AC mode. When you conduct this experiment in the lab, there is something called AC mode and DC mode. When you press the button into AC mode, oscilloscope itself has got a capacitor inside. So that is how DC is blocked and only AC is passing. That way you can see this particular waveform. So if you want only the clipped waveform, you can get it that way. Otherwise, you will get the DC also as such. That is only an example which I told you. Now, how to plot the transfer curve for this? You can see the transfer curve. Normally when input is 0, output is at 3 volts. If that 3 volts is the reference, output is at 3 volts here. And it remains 3 volts throughout. You can see, even in the negative cycle, the 3 volts remains because the diode is conducting. When the input signal goes beyond 3 volts, diode will stop conducting, and that is when the output follows the input, and that is when input rises, output rises. So this is the transfer curve for this particular clipper circuit. And this particular transfer curve also can be seen in the oscilloscope. Now in the negative series clipper, diode is connected in the other direction. So you can see there, here this diode is reverse biased. You can see the cathode is connected to positive terminal of the battery. So this diode remains reverse biased. Always. When this diode will conduct, only when the anode voltage is more than the cathode voltage. The cathode voltage is 3 volts. Only when the anode voltage goes beyond 3 volts, then the diode conducts. Only when the diode conducts, output is available here across. Otherwise, this diode is always off. So, only at this portion, diode is on. In all other portions of the waveform, diode is off. So, remember, in the series clipper, when the diode is conducting, output is present. When the diode is not conducting, output is not there. Remember this sentence? In the series clipper, whether it is positive series, negative series, biased, unbiased, whichever way. In the series clipper, only when the diode is conducting, output is present. Otherwise, output is not present. Conversely, in the parallel clipper, what happens? Output is present only when the diode is not conducting. In case of a parallel clipper, when the diode is conducting, output is not there. You can see here. In the parallel clipper, when the diode is conducting, output is not there. Only when it stops conducting, AC will come there. That is what is here. In the series clipper, only when the diode is conducting, output will be there. When the diode is not conducting, output will not be there. This is a very valid understanding point. Remember this, because when the lab is going to be conducted and when we have lab test or lab exams, there will be viva questions asked about explain the functioning of the circuit. So you should remember all these discussions. Otherwise, there is a tendency that you will remember today and you will forget tomorrow. But that should not be the case if you clearly understand the functionality of the circuit. So for the last time, I will tell once again, in case of a series clipper, when the diode is conducting, output will be present, otherwise it will not be present. In the case of a shunt clipper or a parallel clipper, output will be present only when the diode is not conducting. Any questions? You can always unmute and ask me questions. Otherwise, I will go to the last circuit now. We have seen positive clipper, we have seen negative clipper, we have seen shunt clipper, we have seen series clipper, we have seen biased clipper, we have seen unbiased clipper. The first two circuits were unbiased. The next two circuits were biased. In the sense, DC supply was there in the biased clippers. Now, lastly, we will see one circuit called double-ended clipper. Now, in this case, the waveforms, selected portions can be clipped or chopped out from both directions. That means even in the positive cycle, even in the negative cycle. You can see the circuit. 10 volts peak-to-peak input is given, and there are two reference voltages now, two power supplies here, DC. Both are named here as 2 volts, but you can have different here now. You can have 1 volt, 3 volt, you can have 3 volt, 1 volt, you can have varieties here now, based on the requirement. Now there is one diode which is connected with cathode towards the power supply, another diode connected with the cathode away from the power supply. Then you have a series resistance. Now you can see the circuit. Now this D2's anode is connected to negative terminal of the battery. So D2 is off. D1's cathode is connected to positive terminal of the battery. So D1 is also off. Normally, when we switch on this power supply, when this input is not given, both D1 and D2 are off. That means whatever is the signal there that will come through R1, that will go to the output, that will pass through CRO, that will come back like this. Loop will be complete. Now, what happens when the signal rises beyond 2 volts? When the input signal rises beyond 2 volts, D1 will conduct. D2 will remain off. Why? Because D2's anode is connected to negative terminal. D2 remains reverse biased only. When the anode of D1 is larger than the cathode, then the D1 conducts. When the D1 conducts, what happens? This 2 volts comes across the output. This 2 volts, VR1, that comes across the output. Now, when AC and DC are in parallel, we know that DC is powerful. So, you will have only 2 volts DC plus this 0.7 volts across the diode. That will be there at the output. That means the other waveform which is going to the peak will be clipped off. Now, let us say signal comes back and signal is going in the negative direction. When the signal is going in the negative direction, the same thing happens in the other way. When the signal in the other direction is beyond 2 volts, then what happens here? This anode will be forward biased because the effect of this VR2 is going to be overcome by the input signal in the negative cycle. So when this D2 conducts beyond 2 volts in the negative cycle, then when D2 is conducting, this minus 2 volts will be across the output. You can see this is minus 2 volts now. This will be across the output. So even in the negative cycle, beyond 2 volts, the signal will be chopped off. Now you can vary this 2 volts or this 2 volts to any other value. When you give input to 10 volts, you can vary this up to 9 volts also, right from 1 volt. Any of them, you can have multiple combinations of VR1 and VR2. Based on that, you will have different types of clipped outputs. Now for this particular circuit, what is the output waveform here? You can see the output waveform here. For this particular circuit, beyond 2 volts, there will be no output in both cycles, both in positive cycle and negative cycle. So you will have a transfer curve like this. Beyond the reference voltage, there will be no output even if the input increases. That way, this is the transfer curve. Okay. Any questions here? If you have any questions in this particular circuit, you can ask me. No questions. Fine. Now we have discussed clipper circuits completely. Yeah, any questions? Rohit, ask me.
Sir, both the diodes are in the same direction. Will the output be more?
If both the diodes are in the same direction, circuit can be destructive. If let us say D1 and D2 are in the same direction, what will happen there? Let us say D2 is also in the same direction as D1. D2 will keep conducting, right? If D2 is cathode is connected to negative terminal, now D2 will keep conducting. If D2 keeps conducting, the circuit can be destructive. In the sense, D2 may burn off because you are going to apply more voltage here. And here it is only 2 volts. Excess voltage will become what? Excess voltage will turn into current. Of course, we have this R1 here. The R1 will protect the circuitry. But if D1 and D2 both are in the same direction, it will not work like a clipper. You will get many strange waveforms there. Many strange combinations of these 2 volt DCs along with the AC. That will not be a clipper circuit then. Similarly, if D1 is in the reverse direction, let us say D1 is cathode upwards and anode downwards, then D1 remains always forward biased, right? There is this 2 volts. It will remain forward biased. It will turn off only when the positive cycle goes beyond 2 volts. Otherwise, it will remain forward biased. So we will have strange combinations there. That is the reason what we want is we want only clipper. We don't want any other destructive waveforms or any other strange types of waveforms. That is why these diodes have to be in the same direction. Did you get it?
Yes, sir.
Okay. Any other questions? Only Nidhi and Rohit are active. What about others? Maybe in the future classes, I will selectively ask questions to the other students also. Because lab means more of interaction. Lab means more of hands-on experience. If you don't understand the working of the circuit, then there is no point in you working with the lab also. Isn't it? Because the devices remain devices, power supplies remain power supplies, CRO remains CRO. It is we who are going to use them for achieving a particular objective. So if you do not understand how the circuit works, then there is no point in you conducting the experiment also. Engineering is basically more and more of understanding only. Always, engineering is more and more of understanding, less and less of memorizing. But conversely, I am seeing that mostly students will be memorizing everything. But that is not the idea. If you understand, then you need not memorize. You will have to memorize things only when you don't understand them. Okay. So maybe in the next classes, I will selectively ask questions from the particular students. Otherwise, only Nidhi and Rohit are interactive with us. You may be cursing me, you may be scolding me. Keep doing that. It does not matter for me. Okay. You may be thinking he has to only give the lecture. Why is he asking us? But if it is me only giving the lecture, am I giving lecture to the laptop? I am not giving lecture to the laptop. I am giving lecture to the students. If the students are not interacting in the lab class also, then what does it mean? Only for the sake of attendance you are coming. That is what it means. Fine. Let me proceed to the next experiment. We had seen clippers. Now we have another special circuit called clamper. What I feel is I will not cover all the clampers today. I will cover only 2 clamper circuits today. Maybe the remaining 2 clampers, there are totally 4 clamper circuits. I will cover only 2, remaining 2 let me keep it for the next class. That's what I am thinking, because it may be too heavy for you. One thing, on one side you are trying to understand how clippers are working. Now I should not try to confuse you further by telling you how clampers are working. But I'll have to cover clampers now because this is our second lab. In the second lab, we are supposed to cover the second experiment. So let me at least touch upon the clampers. Remaining portion of the clampers, let me discuss in the next class along with the third experiment. Meanwhile, our lab teachers are compiling all the lab videos. Once all of them are ready, we are going to share the video links with you. Later on, you can go through the video links as well, and you can ask the questions in the Google class. We are going to create one Google class for this particular lab batch, and later on, you will have to submit all your write-ups or whatever in the Google class. Meanwhile, what I would suggest to all the students is, you should have an observation book there with you. You should have a 100-page long notebook with you. For each lab you are supposed to have. Because there is something called continuous internal evaluation, CIE, for which, for the attendance you have 1 mark. For the observation book you have 1 mark. For the practical record you have 1 mark. So each lab session is going to comprise of these 3 marks. Someday we will ask you to show your observation book or your observation book snapshot. You should take a pic and you should upload in the Google Classroom. That also we are going to ask you. So as this is the second lab, remember, from the next lab onwards, you should have a 100-page notebook with you. Even for today's lab also, you will have to write the observation book there. I will share this lab manual with you. But don't just copy whatever is in the lab manual into the observation book. Whatever you understood in whatever way, try to write it in your own way, putting today's date and update your observation book. Later on, I am going to ask you to put its snapshot in the Google class, for which there will be evaluation. Okay. Otherwise, every lab class, simply you are listening and simply you are ending the lab. That is not going to fetch any good results as such. So, without people writing, if they only see and if they only listen, how will they remember? When you see, when you listen, when you understand, always when you write it, you will remember better. That is why keep an observation book always ready with you. From next class onwards, immediately we will be asking you, as soon as the lab session is over, we will be asking you to post that snapshot into the Google class. Okay. Is it fine? Yes or no? At least put your answer in the chat box. If you are hesitant to unmute and speak, put yes or no in the chat box. I'm waiting. Okay. Don't be so stingy that you will have to buy 100-page notebook. Don't be so conjuice. Okay. Have exclusive observation book for each lab. You have hardly only 2 labs, right? One AEC and one DEC. Let me take a small break for drinking water. Fine, let me continue. We are coming to the second experiment called clamper. The meaning of clipping is removing unwanted portion of the waveform. Now the meaning of clamping is the waveform will remain the same. Only thing will, the waveform will be shifted up or down in the DC level. You can see here in the circuit, the input waveform is AC, whereas the output waveform, you can see here, the output waveform is shifted completely up. Means it has become a DC waveform here. How it has happened that way, I'll tell you later when I explain the circuitry. But now, you can understand what is meant by clamper. It is called positive clamper because the waveform is clamped upwards. It is clamped to the positive side. Now AC has become DC, which means what? Earlier current was flowing through both directions. Now the current is actually in only one direction, but it is varying there. Varying in the sense it is going up and coming down. It has become completely DC. How it became DC is a wonderful functionality of this simple circuit. Okay. Now let us see. There is a capacitor here now. Earlier we had only diode and resistor. Now we have a capacitor. You already know that capacitor passes AC and blocks DC. And you already know that diode passes DC and actually it is one way. Diode is one way circuit. In the negative cycle, diode will not conduct. You cannot say that the diode passes DC, blocks AC. You cannot say that way. Diode is conducting in the positive cycle of AC also. So, initially let us assume that when AC is input, the AC is coming this way. Now in the positive cycle, AC is passing through capacitor. In the positive cycle, the diode is reverse biased. In the positive cycle, when the diode is reverse biased, current goes through resistor. You know this property, right? Energy flows to the least resistant path. In the positive cycle, diode has very high resistance because it is not on. RL will have lesser resistance. So in the positive cycle, signal goes in this way. Let me annotate. In the positive cycle, signal flows in this direction. Okay. Now in the negative cycle, what happens? In the negative cycle, it goes in this way. In the negative cycle, diode is the least resistant path when compared to RL. You just visualize one larger pipe and one smaller pipe, larger diameter pipe and a smaller diameter pipe. Now let us say water is rushing into both the pipes. Maximum water will go through the larger diameter pipe because the larger diameter pipe will have lesser resistance. Same way, in the negative cycle, current goes through diode. In the positive cycle, current goes through resistance. Let us say, let it happen for few cycles, maybe 1 or 2 cycles. What happens afterwards? You just look at this diode now. In the negative cycle, when the diode is conducting, there is only a capacitor between the source and the output. Okay. And there is only a capacitor in the negative cycle. Now in the positive cycle, again, it will go through the resistor. In the negative cycle, it will come through the diode. That means in the negative cycle, there's a least resistant path available. Now gradually, because of this least resistant path, the capacitor will get charged like this. let me stop annotating this way and let me start annotating in a fresh way. After a few cycles of signal, now capacitor will become positively charged in this direction and this will become negatively charged. Can anybody tell me why? And this value of charge will be Vm. Can anybody tell me why?
The negative cycle moves towards the left and positive cycle is going towards the right.
Oh, that is fine. My question is, why capacitor gets charged at the right hand side as plus and left hand side as minus? That is my question. Fine, I'll tell you the answer. The answer is, in the positive cycle, capacitor cannot get charged heavily. Why? In the positive cycle, along with the capacitor, there is this resistor. So current goes in this way. But in the negative cycle, diode has much lesser resistance. So all the voltage except this 0.7 volts, all the peak voltage will be across the capacitor. And at that time, there is a maximum current flowing in the loop. In the positive cycle, there will not be maximum current flowing in the loop because there is this resistance. But in the negative cycle, this resistance is totally ignored because of the forward resistance of the diode. So there will be maximum current flowing. So when that maximum current is flowing, gradually capacitor will be charged up to Vm. Now you may ask a question, if the capacitor gets charged, will it not get discharged in the other cycle? It will not get discharged in the other cycle based on one particular condition. The condition is the frequency of the waveform must be much larger than this RC time constant. Which means, see here, T equals C into RL must be much larger. It has to be RL, R suffix L it has to be. So this C into RL, basically we call it as tau, time constant. If the time constant is much larger and if the frequency of the waveform is much lesser, before the capacitor discharges, the next negative cycle comes, right? You would have seen the waves in the sea. Before the previous wave goes back from the shore, the next wave will be coming there, right? When the next wave is coming there, when will there be a steady state at the shore? So same way, now this capacitor will not discharge. Reason is, before the capacitor tries to discharge, it has to discharge through RL only, right? If this capacitor has to discharge, it has to discharge through the load because the diode is now reverse biased. Now, before the capacitor discharges through the load, another negative cycle comes if the frequency here is more. Means T here is, if it is much less than tau, if the period of the waveform is much lesser than the time constant, then before the capacitor discharges, the negative cycle, one more negative cycle comes and the capacitor gets charged again. So after a few cycles, let us say after about 10 cycles of the input signal, the capacitor will remain permanently charged with plus and minus and it will work like a battery here. We can replace this capacitor later on like a battery, that's all. And this battery will have a value of Vm. It is Vm. That means, let us say if this is plus 10 and if this is minus 10. Now here, as this is plus side, when the diode is conducting, this way current is flowing. So when this way current is flowing, naturally this is plus side and this is minus side. That is how capacitor can be represented like a battery now. Now what happens is, because the capacitor remains permanently charged, capacitor is giving additional plus 10 volts to the output now. It is as if we are connecting an AC source in series with the DC source. There is this AC source, there is this DC source. It is as if, let me write a diagram. Let me write a neater diagram by using my right hand. I have been using my left hand because during the lockdown period, due to continuous working with the mouse, I had problems with my right hand. Anyhow, I am an old man, so my right hand is now also paining. That is why predominantly I use my left hand. Now let me try to write the AC source here. I'll have to write using mouse only.
Sir, sorry to interrupt you.
Yeah,
You are still young, sir.
okay. Sorry, let me write it again. Now this is the AC source, and let us say now the capacitor is working like a DC power supply. Imagine this way. Now you'll have to imagine this C is now this battery, which is charged to Vm now. When it is charged to Vm, now imagine these two sources are in series. The input signal is here, then there is this capacitance. They are in series, they are not in parallel. When AC and DC are in parallel, then DC is powerful. But when AC and DC are in series, there is something called superimposition. Superimposition means there will be additional DC voltage superimposed on AC voltage. Now, because of this capacitor's action, it works like a battery which is charged to Vm. So, what happens here is, now this additional Vm which is permanently there, means capacitor cannot discharge at all now, as the next signal keeps on coming. Now, this DC gets superimposed on the input signal AC, and you also know that capacitor passes AC. Now, this capacitor passes AC through it, because of which you can see the output waveform now. Output waveform gets shifted by Vm now. This minus Vm goes up, this Vm goes up. Everywhere it is an addition of plus Vm. 0 goes to Vm, Vm goes to 2Vm, minus Vm comes to 0. Because of this capacitor's charge, you can see the output waveform is clamped up. Clamped means output waveform became completely DC, but with the variation in the amplitude. Now this is a beautiful phenomenon. You may ask where clampers are used. Clampers can be used wherever an AC waveform has to be converted into pure DC waveform without disturbing the shape of the waveform. We want to have the shape of the waveform in the same manner. Again, all such circuits are used in power controller applications. I cannot tell you all those applications now. When you gradually come to third year and final year, you will come across so many such applications in different courses. Okay. But why we are teaching you in third year, second year itself or third sem itself is, these are actually very simple circuits. Simple circuits, but there are some basics to be understood from these circuits. Okay. Any questions here? Now, if this is understood, now my job is easy. I can easily go to the next circuit. The next circuit is going to function in the same manner. Any questions here? No. So remember, for the clamper to work that way, one condition is a must. That is, tau must be much larger than t. That means the period of the waveform must be much lesser than the time constant. Otherwise, what will happen? Otherwise, capacitor will discharge. Let us say the frequency of the waveform is less and the value of RL is also less. Then tau is really very less. So at that time, before the negative cycle comes, capacitor can easily discharge through the load. Then clamping will not happen. If the capacitor has to work like a battery always, then it has to remain charged. That is the absolute condition for the clamper to work. Now let me come to the, tell me.
Even rectifier is used to convert AC to DC, no sir?
Rectifier changes the shape of the waveform, right? In rectifier it is AC to DC, but only portion of the AC, right? Only positive cycle comes, negative cycle will not come. If you use a full wave rectifier, negative cycle also will come as positive cycle. The shape of the waveform is lost there. But here you can see the shape of the waveform is not lost. The shape of the waveform is retained. Only thing is there is a DC shift. You got it?
Sir.
Okay. Let me go to the next circuit now, that is a negative clamper, which is just the reverse of the positive clamper. That's all. It is easy for you to understand now. In this case, again, in the positive cycle, the diode is on. In the negative cycle, the diode is off. So what happens here is simply the reverse. Simply the reverse in the sense, let me annotate. In the positive cycle, the diode is on. At that time, maximum current will flow through the diode. So energy flows to the least resistant path. So there RL will not come into picture. So when it is coming in this way, naturally this is plus. This side is plus, this side is minus. Now in the negative cycle, diode is reverse biased and all the signal goes through RL. Again in the next positive cycle, diode conducts. If this happens for a few cycles, later on this capacitor works like this. It works like the positive plate other side and negative plate this side. Again it is charged the value of Vm. When it is charged the value of Vm, what happens is, now because it is a negative terminal at the output, it is now minus Vm. So this Vm minus Vm becomes 0. This 0 minus Vm goes to Vm minus Vm, and minus Vm becomes minus 2 Vm. So that way the complete AC waveform gets pushed down and it becomes negative side clamper. If you have understood the positive clamper clearly, negative clamper is quite easy to understand. Only thing is the direction of the diode in the reverse way. So I think with this I will stop. Okay, almost more than an hour. Yeah, nearly 1 hour. We have taken a theory class for these experiments. Now you take down a observation book and I am going to post this lab manual in the WhatsApp group. Read again the lab manual, and if you have any questions, you can post it in the Google Class group also, or if you have any other questions later on also, you can post it in the Google Class. Already Prithviraj sir has created a Google Class and you can join into the Google Class. Okay, if you have any questions later on, you can post it there as well. I think, yeah, he has created a Google Class with the code also. You can join into the Google Class. And even in your observation book, today's observation book, you still have time today. Write the observation book, put today's date and take a snapshot, convert it into PDF and post it in the Google Class. We are going to evaluate the same later on. Okay, if there are no more questions, I am going to end the class. Are there any more questions?
No, sir.
Okay, then let me end the class. Post your observation book snapshot in the Google Class. See you in the next lab class.
Already 17 students have joined, sir. I send an invitation to you, sir, to add as a teacher.
Fine.
Yes, sir.
Okay. So let me end the class now.